You are watching channel Number Collage. Through this channel, we make sincere efforts to make you understand and like mathematics in a simple and easy manner. We need your cooperation in this regard. In this video, we are going to understand about the continuity of a function. Consider a piecewise function y equals 1 when x equals 0 or x is negative, y equals 2 when x is positive. Let us draw the graph of this function. Y equals 1 when x equals 0 or x is negative. When x equals 0, y equals 1. So the point 0, 1 will lie on the graph and it has been shown by a solid point. Now the graph of y equals 1 will be a horizontal line which will emerge from the solid point 0, 1, and since x is negative, it will extend towards left of the y-axis like this. Now y equals 2 when x is positive. The graph of y equals 2 will be a horizontal line, and since x is positive, the point 0, 2 will not lie on the graph of this function and hence has been shown by a hollow point. The graph of y equals 2 will be a horizontal line, and since x is positive, the graph will emerge from the hollow point and will extend on the right side of the y-axis. We observe that while drawing the graph of this function, first we have to draw the line, the horizontal line y equals 1 up to the solid point 0, 1, and we had to lift our pencil at the point at the hollow point 0, 2 and draw the graph of y equals 2 towards right. This is exactly where continuity of a function comes into picture. We can say that if we cannot draw the graph of a function without lifting the pencil at x equals 0, then we can say that this function is not continuous at x equals 0. But every time checking the continuity by drawing the graph may not be possible, so we have to find some analytical ways to check continuity of a function. In this function, the values of x are changing around 0. So we will find limit of this function as x approaches 0. When x is negative, left-hand limit will be limit 1 as x approaches 0 negative, which will be 1. When x is positive, right-hand limit will be limit 2 as x approaches 0 positive. This limit will be 2. We have seen in our other video on introduction to limits that when left-hand limit is not equal to right-hand limit, left-hand limit is 1, right-hand limit is 2. Limit of fx does not exist as x approaches 0. So when the limit of a function does not exist, the function is not continuous at that point, in this case at x equals 0. In this example, the piecewise function is, we must note that f of 0 equals 1, which means the value of function fx at x equals 0 is 1. Left hand limit is 1. Right hand limit is 2. Since left hand limit is not equal to right hand limit of function fx as x approaches 0 does not exist. Which means that function f is not continuous at x equals 0. Therefore, sufficient condition for a function to be continuous is that the limit of the function must exist. Consider a piecewise function y equals 1 when x not equal to 0, y equals 2 when x equals 0. Let us draw the graph of this function. When x equals 0, y equals 2, which means f of 0 is 2 and the point 0, 2 will lie on the graph of this function. Therefore, it has been shown by a solid point. Now, when x not equal to 0, y equals 1, which means that the point 0, 1 will not lie on the graph of this function. Therefore, it has been shown by a hollow point like this. When x not equal to 0, y equals 1, in order to draw its graph, we have to find the limit of fx as x approaches 0. So, the left hand limit LHL equals limit 1 as x approaches 0 negative, which will be 1. So, the graph of y equals 1 will emerge from the hollow point and will extend in the negative direction of the x-axis. The right hand limit equals limit 1 as x approaches 0 positive, it will be 1. The graph of y equals 1 will be a horizontal line emerging from the hollow point 0, 1 and will extend in the positive direction of the x-axis. We observe that while drawing the graph of this function, first we drew the point 0, 2 and after that to draw the hollow point 0, 1 we had to lift our pencil. So when we cannot draw the graph of this function without lifting the pencil at x equals 0, which means that this function is not continuous at x equals 0. Now, the important condition that we get, that f of 0 equals 2, which means the value of function at x equals 0 is 2. The left hand limit is 1, right hand limit is 1, that is LHL equals RHL equals 1. But which means the limit of the function exists and this limit fx as x approaches 0 is not equal to f of 0, which is 2. So these are the conditions for a function to be not continuous. Now we will define continuity of a function. For a function fx to be continuous at x equals c, two conditions are important. Number one, fc must exist, which means value of the function at x equals c must exist, or function f must be defined at a real value c. Number two, limit fx as x approaches c must be equal to f of c. Now for this limit fx as x equal, here limit fx as x approaches c must exist, and for this to happen, limit fx as x approaches c negative must be equal to limit fx as x approaches c positive. That is, left hand limit must be equal to right hand limit. So in other words, we can say that for a function to be continuous, left hand limit must be equal to right hand limit must be equal to value of the function at x equals c. Now, to understand the concept of continuity, let us solve a few examples. Check the continuity of function fx equals 2x plus 3 at x equals 1. 2x plus 3 is a polynomial function, and polynomial function is defined on the set of real numbers. So at x equals 1, the value of the function f of 1 will be 5. Its left hand limit as x approaches 1 negative will be 5. Right hand limit as x approaches 1 positive will be 5. Left hand limit equals right hand limit equals f of 1, 5, 5 and 5. We say that f is continuous at x equals 1. Next, examine if the function fx equals x square is continuous at x equals 0. X square is a polynomial function. Polynomial function is defined on the set of real numbers. At x equals 0, its value at x equals 0, f of 0 will be 0. Left hand limit will be x square as x approaches 0 negative, it will be 0. Right hand limit of x square as x approaches 0 plus will be 0. So left hand limit equals right hand limit equals f of 0 equals 0. Therefore, we can say that function f is continuous at x equals 0. Next, show that the function fx equals x cubed plus 3 when x is negative and fx equals 1 when x equals 0 is not continuous at x equals 0. Function f is defined at x equals 0 because it is a polynomial function, and polynomial function is defined on the set of real numbers. Hence, f of 0 will be 1. That is, the value of the function at x equals 0 is 1. When x not equals 0, fx equals x cubed plus 3. See here, x cubed plus 3. Left hand limit will be, as x approaches 0 negative, it will be 3. Right hand limit, as x approaches 0 positive, will also be 3. Here left hand limit equals right hand limit equals 3, which means that limit of the function as x approaches 0 exists. But f of 0 is 1 at x equals 0. Left hand limit is equal to right hand limit, but it is not equal to value of the function at x equals 0, that is f of 0. Hence, we can say that the function is not continuous at x equals 0. Next, discuss the continuity of the function f given by fx equals mod x. Fx equals mod x, which means function fx is defined as fx equals minus x when x is negative, fx equals x when x is either 0 or positive number. First, we will discuss the continuity at x equals 0. F is defined at x equals 0. So f of 0 will be mod 0, which will be 0. According to this, left hand limit will be, as x approaches 0 negative, it will be 0. Right hand limit at equals right hand limit, which also equals f of 0, which is 0. Hence, the function f is continuous at x equals 0. Number equals a real number c, which is a negative real number. F of c will be minus c according to this rule. Left hand limit will be, as x approaches c negative, it will. Hence, we can say that f is continuous for all negative numbers. Number 3. Now we will discuss the continuity at x equals a real number c, which is positive. C, according to this, which is same as fc, because fc is also c here, which means that f is continuous for all real numbers, all positive real numbers. Function f is continuous on the set of real numbers. Next, discuss the continuity of function fx equals x cubed plus x squared minus 1. F is a polynomial function, see here. Hence, it is defined on the set of real numbers R. For any real number c, f of c will be c cubed plus c squared minus 1 according to this. Left-hand limit as x approaches c negative will be c cubed plus c squared minus 1. Right-hand limit as x approaches c positive will be c cubed plus c squared minus 1. Left-hand limit equals right-hand limit equals f of c, which is c cubed plus c squared minus 1. See here, which implies that f is continuous at x equals c and hence continuous on the set of real numbers R. Next, discuss the continuity of function fx equals 1 upon x when x not equal to 0. We have f of c equals 1 upon c. And limit 1 upon x as x approaches c will be 1 upon c, which is same as f of c. See here. Hence we can say that f is continuous